Helium neon laser is one of the most popular continuous wave laser. Ali Javan and his co-workers developed the helium neon laser in 1961. It was the first gas laser, and in this video I will describe about the helium neon laser, mainly the working principle of helium neon laser, the advantage, disadvantage, and the application of helium neon laser. So this is the schematic diagram of helium neon laser. So helium neon laser consists of three essential components needed for lasing action. Number one, pumping source, that is the high voltage power supply. Second, active medium where helium neon gas mixture is introduced. And third, the resonating cavity where neon atoms are active and enable for lasing action, provided that these neon atoms are exciting with the help of the helium atom. Here the cathode and anodes provide current through the helium neon gas mixture. A helium neon laser consists of large, narrow discharge tube filled with helium and neon gases in the ratio of 10:1. This tube is enclosed between the fully reflected mirror and the partially reflected mirror, which serve as a optical cavity. The two ends of these windows are set at Brister's angle, so reflected radiation enter into the tube become polarized. The distance between the mirror is equal to an integral multiple of half wavelength of the laser light and supports the standing wave pattern within the resonator system. So, in order to understand the operation of helium neon laser, let us take help of the energy level diagram. Due to the discharge in the mixture of two gases by applying high voltage, the helium atoms are excited by the impact of accelerated electrons in discharge tubes for its less mass in comparison to neon atom. That means the helium atoms are lighter than the neon atoms. As a result, some atoms of helium are raised by electron collision to the metastable state like F2 and F3. The number of so excited atoms gradually build up as no radiative transition to the lower state is possible. Now, some of the excited states of neon gas are lower than very close to the aforesaid metastable state of helium gas. For this reason, when atoms of helium in states F2 and F3 collides with those neon gas in the ground state, energy is U1, exchange of energy takes place among them. As a result of this type of collision between atom of the two gases, some neon atoms get excited and raised to the higher energy state, that is the E4 and E6, and returning of the helium atoms to the ground state through de-excitation occurs. The process of the energy transfer has a high probability as the states F2 and F3 are unstable. The discharge in the cavity thus continuously increases the population of neon atoms in excited state, that is the E4 and E6. So population inversion takes place in between E4 and E6. That means, so E6, E4 and E3. The various transition between different pair of layers lead to the emission of radiation of wavelength. So from E6 to E5, the laser wavelength of 3.39 micrometer, which is in IR range. Second one is E6 to E3 with laser of 632.8 nanometer, and finally E4 to E3 transition with laser of wavelength 1.15 micrometer, which is in IR range. The excited neon atoms then fall from the level E3 to E2 by spontaneous transition, resulting in emission of photon of wavelength lambda, that is equal to 600 nanometer. The helium neon laser is more directional and more monochromatic than any solid laser, as it is a gas laser. So this helium neon laser, the population inversion due to the collision. So the use of helium neon laser, it is used in interferometry, it is used in laser printing, also in the barcode reading, holography, then for larger distance measurement, that is in laser modulation telemetry, and finally in the target aiming device as for guns. So there is some advantage of helium neon laser. First one is helium neon laser emits laser lights in the visible portion of the spectrum, operates without damage at higher temperature, higher stability, and the low cost. And there are some disadvantages of helium neon laser, that is helium neon lasers are limited to power, lower power task, low efficiency, and low gain. Thank you for watching this video.